Greeting of the day. I am Rajkumar Parashari and I love doing physics. Today I am here with the dimensional formula of distance covered by a body during nth second of its journey. Here are the three different clips which I have picked up from different resources available on the internet. This formula of distance covered by a body during nth second of its journey, provided motion is uniformly accelerated, has been the main culprit which keep confusing students as well as teachers alike. Look at over this. This is the velocity, and this is in fact the initial velocity. Dimensional formula of initial velocity happens to be Lt minus 1, because the dimensional formula of initial velocity is Lt minus 1. So people, they take it for granted that the dimensional formula of distance covered during nth second of the journey should also be Lt minus 1. And look at this clip over here. Over here the statement is distance traveled in the nth second has the dimension of the velocity. This is a false statement. As long as it's a distance traveled, dimensional formula got to be length only. Dimensional formula got to be L only. Is that right? So distance covered could be in the first second of the journey. It could be in the second of the journey. It could be in the third second of the journey. Dimensional formula of distance got to be L. I will justify it later. You need to wait for some time. And the second statement is because it is the distance traveled in one particular second. Yes, I agree to it that the distance traveled in the nth second is the distance traveled in a particular second. And you see over here, these are four different parts. Options: option A, option B, option C, and option D. So instead reading all these options, you need to relook yourself. Over here, statement first is false. Statement first is false. Is that right? And statement 2 is true. Is it okay? And the option given in this caption is A. So this option A definitely is false statement. Now you see, if I look at the clip number 2, the distance traveled in the nth second is equals to distance upon time. This is totally rubbish. It cannot be distance traveled in nth second. This is distance traveled. It cannot be distance upon time. So let's not waste our time in whatever written over here. They have written dimensional formula of distance is L, dimensional formula of time is T. So dimensional formula of distance traveled in nth second should be equal to Lt minus 1. This is totally incorrect approach. Now you see, now let's come to the part we already know. I want to give one or two more point just to justify that distance traveled in the nth second of the journey is L. The dimensional formula is L for the distance traveled during nth second of the journey. Now you see, I presume that you already know what nth second stand for. For that you need to search my one of the video that in that I have derived formula for the nth second. This happens to be t is equals to 0. Particle is here and has some initial velocity u. T is equals to 0 happens to be the time of observation when particle is at position A and crossing point A with speed u. And you see, t is equals to 1 second, and this is t is equals to 2 second. This is t is equals to 3 seconds, and this t is equals to n minus 1 second, and this is t is equals to n second. And right from this place to this place, this is the distance covered in n minus 1 completed seconds. Is it right? And n completed second means what? Right from 0 to n minus 1. This happens to be distance covered during n completed seconds. And you see, from here till this point, this happens to be distance covered. This happens to be distance covered during n completed second. Distance covered during n completed seconds. And you see, class, this distance right from here till here, this is the distance covered during nth second. This is happens to be distance covered during nth second of the journey. If I represent it by the symbol xn, n is a subscript, so the xn, this should be equals to xn minus 1 as per definition. Dimensional formula of distance covered during n completed second is L. Dimensional formula of distance covered during n completed second is L. Dimensional formula of distance covered during n minus 1 completed second is also equals to L. So the dimensional formula covered, during nth second of the journey should also be equals to L, because this is by definition, this is the distance covered during nth second of the journey. Is that right? Now you see, if I try to give you another viewpoint, I mean, how really we can justify it, just look at, I mean, this is what has been confusing to many, that x in distance covered during nth second of the journey is equals to u plus half a 2t minus 1, and this is what is sometime practiced, in fact many times. So the dimensional formula of u is lt minus 1. And if I look at over here, dimensional formula of half is 1, dimensional formula of acceleration is lt minus 2, and dimensional formula of this term, dimensional formula, I mean, many people, they will not be able to justify that this is equals to t and this is equals to lt minus 1 plus lt minus 1 equals to, this is dimensional formula of right hand side, this is formula of right hand side, this is equal to, this is equals to lt minus 1. This is totally incorrect approach of doing. Dimensional formula of right hand side is lt minus 1 and dimensional formula of left hand side is also equals to lt minus 1. And this is what I am telling you, this right hand dimensional formula of right hand side is not lt minus 1 but it is L. Dimensional formula of left hand side is also equals to L. And let's see that how really I should be able to justify this for you. I mean, definitely I will have to go into details of the derivation of this result to justify this, how really we can proceed. Though, I mean, this is not required. Over here, I have already justified the dimensional formula of nth second, because this is distance covered. Dimensional formula of distance covered during nth second of the journey got to be L only. But anyway, if you're interested, then definitely I should be doing some efforts for you, that you see xn, this is distance covered during nth second of the journey. This is equals to how much? This is equals to un plus half a n square. Is it okay? So what I have done, I have written this value, the distance covered in nth second of the journey, and then minus u n minus 1 plus half a half a n minus 1 whole square. Is that right? And you see, just open it up. This is un plus half a n square. This is minus, open the bracket, multiply these two. This is u is to n, multiply these two. This is equals to minus u once, but minus is outside, so this should be plus. Then next, this is equals to half a, this is n square minus 2n plus 1. I have opened up this square bracket, so this should be minus sign. Is that right? So you see, instead cutting this directly, let's wait for 1 or 2 more steps. This is un plus half a n square minus un plus u minus half a n square, and this is plus half a is to 2n, and this is minus half a is to 1. Now you see, over here we need to be slightly careful as we try to justify that the formula, dimensional formula of distance covered during nth second of the journey is L only. You see, if I say 6 second, this is equals to 7 minus 1 into s, and this is equals to 7s minus 1s. Open the bracket. So this is what is important. You need to be slightly careful. This is not 1. This is not 1. This is in fact 1 second. Is it right? This is n. This is not n. This is n second. Is it right? So over here, let's write unit with every corresponding term, and this is what I am writing for you. This is equals to u with unit. This is meter per second. This n is same as ns. Is that right? You see, this is let me do it here. This is n second, and then n minus 1 second is equals to n second minus 1 second. This is what I will be using. And you see, u into n is this, then plus half a. A is a meter per second square multiplied by, this is in fact n into s, product ns. So this is ns whole square, and then next minus u is, you already know, this is u meter per second multiplied by n second, and then plus u meter per second. The next, just see that u has been multiplied by 1. In fact, u has been multiplied by 1 second. Is that right? So this is u multiplied by 1 second. So this is 1 second. U meter per second multiplied by 1 second. Now next, let's see that what do we have over here. This is half a. The unit of a, the unit of this a, the unit of this a is a meter per second square, and this is n square. This is n square, this part. So this is n square s square. Is it okay? Now let's see, these are the two terms left, this term and this term. Let's try to write properly. This is half plus half a, and the unit is meter per second square. And the next term is 2n. Is it 2n? Is it only 2n? Be slightly careful. As I write this, just check what I am writing. N minus 1 whole square. In fact, in place of this, I wish to write ns minus 1s whole square. Just open this bracket. This is n square s square minus 2 times ns into 1s, and then plus 1s whole square. Is that right? And if you want to take, you can take second square as common. So what is left? This is n square minus 2n plus 1, and outside the bracket this is second square, and over here I have not taken second square as common. So this 2n, so what you find written over here, this 2n, basically 2n multiplied by second square. So see over here, this term, this 2n, you see this 2n in fact is 2n into second square. Is it okay? Then minus half a. Can you tell me this is 1 or this is 1 second square? So this is 1 meter per second square multiplied by 1 second square. This is what I mean. I have written this equation. Here I have rewritten, but I have rewritten every single term with units. If you see carefully, then you will notice that second will cancel with second square will cancel with this second square. Is it right? And this second will cancel with this second will cancel with this second. This is, I guess, this is meter per second square. So this second square will cancel with this second square, and this second square will cancel with this second square. This second square will cancel with this second square. If you see carefully, then every single term has unit meters. This is u times meters. This is half a meters, half an into meters. Every single term has unit meter. So anyway, let's try to justify. You need to see it carefully. This term also has unit meter. This term also has unit meter. This term also has unit as meter. This term also has unit as meter. This term also has unit as meter. Let's write. Anything cancelling? Can you notice? So see this term is cancelled with this term. This was also obvious here. This term. You see, this term was cancelling with this term, and this term was cancelling with this term. But I just retained these terms only for this step, just to make things clearer. So this term is cancelled with this term. Even this term will be cancelled with, can you guess with which term? This will be cancelled with this term. Is it right? Half a n square. So the remaining terms will be the third term. This is the remaining term, and this is also the remaining term. Is it right? These are the two remaining terms, and which is the other remaining term? Can you see? This is the this has already been cancelled with this. So the remaining terms are 3. So this is 1, 2, and the 3. Let's write on the next page. The remaining term, this is equals to u only. Is it okay? This is equals to u plus, I am now skipping the units, and this term, this is the remaining term, and what this term is, half a into 2n. This is half a multiplied by 2n. And the last term, this term, can you see, this is half a minus half a, only minus half a. This is minus half a, and every single term has unit as meter. Can you see this? I can show you again for your benefit. This term has unit. Can you check over here? This second is cancelled with this second. So what is left? U meters. Is that right? So this u has unit as meter as expected, because this has unit as meter. So this will also have unit as meter. Now this term also has unit as meter. Okay, there's some repetition. I will not mind. I guess you should also not. So second square and second square is cancelled. So what is left? You see, only the unit is meters. So the unit is also meter, and this is also meter. You have seen it. Second square and second square is cancelled. This is the unit left is meter. So this is half a. So I guess you should be convinced. You can see this video again to see that every single term has unit as meter. Now next, So this xn, this is equals to u, take half a as common, this is 2n minus 1, and over here every single term has unit as meter. So this formula is dimensionally correct, this formula is dimensionally correct. Why? Because every single term has same unit equal to L, half into half a into 2n minus 1. Dimensional formula of all three terms is same, equal to L, and hence this formula is dimensionally correct. Is it right? I guess I have given you enough idea how really we should be looking for it. So if you have liked this video, then please do subscribe it so that you get notification in time. Thank you so very much. God bless you.